stop cleaning your MAF sensor. This way it's silently killing your engine. I've seen hundreds of cars shaking, losing power, and triggering the check engine light, all because of one small mistake when spraying. The problem is, most people think they're doing it right. But in the next few seconds, you'll see exactly how a MAF sensor slowly dies and how to avoid it before it's too late. If you've ever heard someone say, "Just spray it clean and you're fine," watch this part closely, because with a single wrong spray, you can burn out a $450 sensor. And worse, you won't even know until that check engine light comes back on again. Don't blink, I'll show you the exact moment it happens. Inside the MAF sensor is an ultra-thin platinum wire thinner than a human hair. This wire measures the amount of air entering the engine so the ECU can calculate the correct amount of fuel. But if you spray too close or use the wrong chemical, the jet will destroy the protective coating on the wire. Once that coating peels off, the wire will get contaminated or scorched every time the engine runs. The ECU starts receiving bad data, thinking the engine is short on air or rich on fuel. The result? Higher fuel consumption, reduced power, and a glowing check engine light. Many people blame spark plugs, the fuel filter, or the oxygen sensor. But in reality, the MAF sensor is the culprit. Worse still, if you use WD-40 or brake cleaner, the oil content in them will leave residue. When the sensor heats to over 300 degrees Celsius, that residue bakes on and forms a fixed carbon deposit. At that point, the sensor is permanently blind. It can no longer measure airflow accurately. The ECU then enriches the mixture. Thinking less air is coming in, the engine runs rich, belches black smoke, and wastes fuel. And you might think the car is weak because of the spark plugs or injectors, when in truth it was just one wrong spray. It all starts with a small misconception, thinking that spraying it clean is enough. Clean is good, but cleaning the wrong way is a disaster. And here is the exact method professionals use every day. Let's walk through it step by step. Here's the safe and proper way to clean a MAF sensor exactly how professional technicians do it. Step 1. Disconnect the MAF sensor connector to ensure safety. Step 2. Gently remove the sensor. Never touch the tiny wire inside, even a light touch can alter the signal. Step 3. Use only a cleaner specifically labeled MAF sensor cleaner. Do not use carb cleaner or WD-40. Step 4. When spraying, keep a distance of 6-8 inches. Let the mist fall lightly onto the surface. Do not spray directly or with high pressure. Step 5. After spraying, place the sensor in a dry, ventilated area and let it air dry for 15 to 20 minutes. Never blow it with compressed air, never wipe it, and never reinstall it while still damp. Many people replace spark plugs, fuel filters, even oxygen sensors, forgetting that the real issue started with a MAF sensor cleaned the wrong way. When done correctly, the sensor will read more accurately, the idle will stabilize, the engine will regain power, and fuel efficiency will improve. But if done incorrectly, the signal will fluctuate, the ECU will misread, and you could waste hundreds of dollars over one small mistake. If, after cleaning, your car still shakes, feels weak, or the check engine light stays on, it's likely your MAF sensor has already begun to fail. Watch the next video, 9 bad mass airflow sensor symptoms that could destroy your engine, to learn the 9 warning signs of a failing MAF sensor and know exactly when to replace it before it's too late. I once had a customer who cleaned his MAF sensor every time he changed his oil but used the wrong cleaner. After 4 months, his car kept showing lean mixture codes, and the check engine light came back again and again. He replaced the O2 sensor, the air filter, and the spark plug, spending over $700, but the problem remained. When inspected, the wire inside his MAF sensor had turned burnt brown, and its protective coating was completely destroyed. Just one wrong spray had ruined a $450 sensor, and he never even realized it. From that story, remember this one rule. Always read the label carefully before using any cleaner. If it doesn't explicitly say, mass airflow sensor cleaner, do not spray it on your MAF sensor. Other cleaners, even if they look similar, leave oily or chemical residues that erode the sensor wire and cause inaccurate readings. When cleaning, handle the sensor gently, no need for forceful spraying. The MAF sensor is extremely sensitive. It doesn't need power, it needs precision. You've cleaned your MAF sensor, but your car still shakes, hesitates, or consumes more fuel than usual? Here's the good news. You don't need a garage or any expensive tools. With just a few minutes, a simple multimeter, or even a cheap OBD2 scanner, you can find out whether your MAF sensor is still working properly. In this bonus section, I'll show you 3 super simple ways to test your MAF sensor right at home. The first method takes less than 10 seconds, and it can tell you whether your sensor is dirty, weak, or completely dead. Method 1, the quickest test. Unplug the MAF sensor connector while the engine is running. If the RPM slightly increases or the idle becomes smoother, it means the sensor has been sending incorrect signals to the ECU. When the engine runs better after unplugging the sensor, it indicates that the current MAF data is no longer accurate. This is the earliest sign that your MAF sensor is weak or heavily contaminated. Method 2, the accurate test using a multimeter. Turn the ignition key to the on position. Engine off. Set your multimeter to the 20-volt DC range. Locate the signal wire, usually the middle wire, on the MAF connector. Insert the red probe into the signal wire and the black probe to ground. Start the engine at idle. Voltage should read around 1 to 1.2 volts. When revving to 2,500-3,000 revolutions per minute, voltage should rise smoothly to 2.5 volts. At wide open throttle, voltage should reach 4.5 volts. If the voltage doesn't change as you rev or jumps erratically, the sensor is bad and needs replacement. Method 3, the modern and easiest way, using an OBD2 scanner. Plug the scanner into the diagnostic port under the steering wheel. Turn the ignition on and select Live Data. Find the line showing MAF G divided by S, the airflow reading in grams per second. At idle, normal values range from 2 to 7 grams per second, depending on engine displacement. Golden rule: the MAF should read approximately 1 gram divided by second per 1 liter of engine displacement. Examples: 2.5 L engine about 2.5 GS, 3.6 L engine about 3.6 GS. As you press the accelerator, the reading should increase smoothly. If the value stays flat or doesn't respond, the sensor is dirty or its signal is faulty. If the idle reading is unusually high, for example, over 10 grams per second, your car may have a vacuum leak in the intake system. Interpreting the results. After these 3 tests, you'll know exactly what condition your MAF sensor is in. Dirty needs cleaning. Weak, check wiring and connector. Dead needs replacement. Many people see a shaky idle or a check engine light and immediately assume the MAF sensor is bad. But that's not always true. Sometimes the issue lies elsewhere, and the sensor is just the victim. If your engine shakes at idle or RPM fluctuates, the MAF may simply be dirty or its internal wire degraded. Clean it properly and reset the ECU, then drive for 10 minutes to let it relearn the airflow data. If the sensor voltage doesn't change with throttle input, or the OBD2 reading, G divided by S, stays the same, the MAF is dead, it must be replaced. If voltage fluctuates wildly or the readings jump erratically, the issue often isn't the sensor itself, but a loose connector or broken signal wire. Check the pins, clean them with contact cleaner, and reconnect firmly. If the MAF reading is too high at idle, say 10 plus G divided by S at 700-800 revolutions per minute, you likely have a vacuum leak. Inspect the intake hose, PCV line, or the gap between the air filter and throttle body. Even a small leak can cause false readings. If the MAF reading is too low, around 0.51 grams per second at idle, check the air filter. A clogged or dirty filter restricts airflow, causing the ECU to reduce fuel and the engine to lose power. When you know how to interpret this data, you'll never again be misled by a wrong diagnosis or unnecessary replacement. Just a few simple tests can save you hundreds of dollars and help you truly understand your own car. When the check engine light comes on, the MAF sensor is often one of the most common reasons. If you use an OBD2 scanner, you might see error codes ranging from P100 to P104. Here's what each code means, so you can understand them more easily. P100, General MAF Sensor Malfunction. This means the car isn't receiving a proper signal from the sensor, possibly due to a wiring issue, a loose connector, or a dirty sensor. P101, MAF Sensor Operating Out of Range. The MAF signal is either too high or too low, causing the ECU to miscalculate the correct fuel amount. P102, signal too low. Usually happens when the sensor is heavily contaminated or the power supply is weak. P103, signal too high. May occur when a wire is shorted to power or when the MAF housing has an air leak, causing false airflow readings. P104, intermittent or erratic signal. The car may run fine at times, then feel weak, with unstable idle or fluctuating RPM, often caused by a loose connector or an internally broken signal wire. There are also other trouble codes indirectly related to the MAF sensor that many people don't realize. P171 and P174, system too lean, not enough fuel. The MAF is underreporting the actual air entering the engine, causing the ECU to inject too little fuel. P172, P175, system too rich, too much fuel. The MAF overreports airflow, making the ECU inject excess fuel, leading to poor MPG and a smell of raw gasoline. P113, intake air temperature sensor, high input. This sensor is often integrated inside the MAF. If the MAF fails, this code may also appear. P68, throttle body and MAF signals mismatch. When these two sensors don't agree, the ECU suspects the MAF is inaccurate. P2000, 195 and P2197, O2 sensor indicates lean mixture. In reality, the MAF is feeding incorrect data, causing the ECU's air-fuel calculations to go off balance. P1000, 101, MAF sensor fails self-test. Very common in GM and Ford vehicles. It means the ECU's built-in MAF test did not pass. Though these codes look different, most of them stem from the same cause, a dirty or misreading MAF sensor. If you see any of these codes, check the air filter, clean the MAF using a dedicated MAF sensor cleaner, and reset the ECU before considering replacement. Sometimes, a clogged or incorrectly installed air filter can misdirect airflow. A vacuum leak in the intake system can also make the ECU miscalculate incoming air. In other cases, a loose connector or oxidized wiring can cause intermittent signal loss. Some cars also need time to relearn MAF data after cleaning, so a temporary fault code may remain until you drive a few miles or perform an ECU reset. When you encounter codes like P100, P101, P171, or P174, don't rush to replace the sensor. Check the air filter, intake hoses, wiring, and clean the MAF first. In most cases, the issue clears up and the engine runs smoothly again, saving you from spending $450 on a new sensor. I once worked on a Nissan Altima 2.5 liters with this exact issue. A thin film of oil from an over-oiled air filter had coated the MAF sensor, making the car sluggish and burning extra fuel. After cleaning it with MAF sensor cleaner, resetting the ECU, and replacing the air filter with an OEM one, the engine ran perfectly, no more error codes. The lesson is simple. Don't replace the sensor right away. Clean it properly first, because sometimes a single proper cleaning can save you hundreds of dollars.